Right, we got 4 computers in the left and the LAN network is 10 network. We are connected to WAN side using G001 interface on the edge router. And the WAN IP is, what is the WAN IP? What is the WAN IP? Correct, 20001. This is LAN. The side greeny field is LAN, local area network. The other side of the edge router that connects to the ISP is the WAN side. You see, WAN side is public. WAN side is public. Now, usually on the edge router, we used to write a default route. Let me write the default route. IP route, any network, any subnet mask, send it to 200010. Whose address is 200010? Correct. Why are we writing default route towards ISP? Because ISP is responsible to take us to all destinations in the internet. So, if a member of a LAN wants to ping 30001, which is the internet device, like Yahoo, Facebook, YouTube, Gmail, 30001 is like some destination in the internet. If a member of a LAN wants to reach someone in the internet, where the packet should be forwarded to the ISP. That's why I wrote this default route saying any destination you do not know, you can send the traffic to this guy. This guy is ISP. He can route the packet. Alright, done. What is next? Will I be able to ping now? Let me show you. The ping won't happen. I'll go to 10001 and try to ping ping 30001. The ping will not happen. What is the reason? The ISP do not know route to reach any private network. Show IP route. You see, there is no 10 network here. Even in the real world, ISP routers will not have route to reach private networks. Debug IP packets. You see, now I'm going to ping again from here. The ping won't happen, but you can see ISP is forwarding some traffic coming from 10001 to 30001, and when 30001 replies to 10001, ISP router says, "Naku gottilla, I do not know. Tellede." It says, "I do not know," unroutable. You see, to the destination 10, unroutable. Listen, the traffic from here is passing through the ISP router. That's what you see here. And you can see that traffic is coming from the source, going to the destination, which is the PC behind ISP. I asked you to assume that as a Yahoo. So it goes to Yahoo. Even Yahoo responds back, you see, source. It is responding, and the traffic comes to ISP router. ISP router checks the routing table, looks for 10, but there is no route for 10. No route to reach 10 network. Yeah, in the real world also this is what happens. When you don't do natting, your packets will go to Yahoo, but Yahoo cannot reach you back because Yahoo do not know your private networks. This 10 network, no, 10001, at least 1 million people will have this IP address in the world, minimum. At least 1 million people will have this IP address. Yeah. They're all private, no? So every organization will have some private network. Most of the people will have 10 as a private network because 10 is big in size than 172.16 and 192.168. Okay. What is the solution? Do natting. Let me explain you what happens when you do natting now. We have seen natting a couple of times theoretically. Now I'm going to explain you with this. You see, when I go here and ping 30001, this PC receives the packet from 10001 and it replies saying, source 30001, I am responding to the ping came from 10001. So when this packet comes to the ISP router from the PC, ISP router says unreachable, right? You saw that, unroutable. So what we are planning to do is, instead of sending the packet out, like this, source 10001, destination 30001. When we say I'm coming from 10001, this guy is going to respond. This guy is going to reply to 10001. But 10001 is unknown to ISP. So instead, if I put before sending the traffic out, if I put this address, now this PC will respond to 20001. And this router knows where is 20001. It can forward the packet to this guy. And this guy knows that 10001 only I have natted to 20001. So any traffic coming to 20001, it will put 10001 and deliver the packet here. You understand? This router can now reach. Earlier, when this was 10 without natting, when this was 10, this router was unable to reach. Public routers cannot reach private network. But after we change the source address, from 10.0.0.1 to 20.0.0.1, after we do this mapping, the packet went with a source which is known to the ISP. Did you understand? So after we do natting, static natting, we will be able to ping. That's what I want to tell you. Now, next thing what I want to tell you is which address to use. Here, I'm using this address, which is already in the interface. But if you have another address, you can use it. Like let's say I got another address 20.0.0.2. See, this address need not to be there on any interface. I repeat, 20.0.0.2, I would like to do mapping. I would like to do mapping to 20.0.0.2 whenever traffic comes from 10.0.0.1. 10.0.0.1, I want to do static netting using 20.0.0.2. Where is this 20.0.0.2? Is it there in any interface? No. Is it necessary to be on in an interface? No. So, I'm trying to help you understand that you need not to use the physical interface address. If you have another address, you can give that another address dedicatedly to that 10.0.0.1. Yeah, okay, that's the plan. Now, we are going to use 20.0.0.2. I am going to do it first, then you will do it. You see, once again I am pinging, it won't ping. And you can see that it is trying to respond back, it is trying to reply back to 10.0.0.1, which is unroutable. Now I'm going to the edge router to do natting. Very first thing you need to do is the direction. You need to go to this LAN side and say IP NAT inside. And the WAN side you should say IP NAT outside. And this is applicable for all three type of NAT. You have to put this command in all three NAT. So, if I put it now, I will not remove when I take you to the next dynamic NAT. Now we are going to do what NAT? Static NAT. This inside and outside is needed for dynamic NAT, static NAT and dynamic NAT overloading PAT. If you fail to put this command, the NAT configuration that you do won't work. Let us first do this one. This is the basic primary thing. Interface G000 IP NAT inside. Next, interface G001 IP NAT outside. Please do up to here. Now, simple. I didn't do much. I just explained you what we are going to do. And then I did only this configuration. NAT inside and NAT outside. Nothing more. I did not do static NAT. I did not do any NAT so far. Okay? Just put these two commands on these two interfaces and get back to me. So what next we are going to do is the static NAT. You see, IP NAT inside means, when traffic when IP traffic comes from inside, we just now defined inside. Any traffic coming to G000 is inside. IP NAT inside, source. Statically you do the natting. Source is coming from where? Inside. It needs to be statically translated to, you see, you can give which address you want to translate, 10001, this address, to which address you want to translate. As we discussed, we want to translate to 20002. Remember, I told you that this address that I'm using for translation, the address that I'm using for mapping, doesn't need to be there on any interface. You see, we don't have 20002 on G001. We have just got only 20001. It is okay. It is okay. Right? Any question on this? Okay. Do this. Your static NAT is over. See how easy it is. To verify, this is the command. Show IP NAT translation. Type this and see what you see there. You should see exactly what I am seeing here. Now let us verify by pinging. This ping will definitely happen now. Earlier I was not able to ping, but this time you see, I'm able to ping. Don't ping now. You just watch me doing this. It will ping now, and then I'll show you some. Okay, look at this. It's pinging. Now go to ISP router and see the debug. You see, now the traffic is not coming from 10001. It is coming from 20002. And the reply is also going to 20002 from 30001. So NAT is happening. Right? How did I get this debug? I use this command debug IP packet, but now I am going to cancel because I have shown you the proof. To stop the debug, you should say undebug all, you all. Have you noted this command? Okay, now even in this router you will have another proof. Same command, show IP NAT translation. You see, last time it was only showing this much. It says if any traffic coming from this, I'll translate it to this. But now if you see, it has translated 4 packets. Now if I ping again, I'm pinging again. So earlier 4 packet, now another 4 packet. Let's go and check now. Okay, ping again. See, the table will get refreshed very soon. Okay, now let's go. You see, more packets. Do you see this? It's happening. Translation is happening. When traffic is coming from here, it is translated to this, so that the reverse NAT also can happen. You're able to ping, you're able to send the ping message, and you're able to receive the reply from 30001. See, even though ISP do not know the route to reach 10 network, we are able to ping from 10001. It is because when the packet goes to the ISP, it is not having any IP address identity starting from 10. It takes 20002 before sending the traffic out. As a result, ISP only need to route the packet to 20, not to 10. ISP knows where is 20. Did you understand static NAT? Now you verify. You do all the verification that I did for you now. This is the homework. Just now we did translation from 10001 to 20002. Likewise, you do translation from 10002 to 20004, 20006, 20008. As I told you, the mapped address need not to be assigned to any physical interface. Just try these things and ping, and then verify, debug and verify, show IP NAT translation command you use and verify, and then you come to class, we will finish the other one. See, this NAT table will get refreshed. So as soon as you ping, you should come and see. You should not see after 5 minutes. It won't be there. Huh? So just 3 more lines you need to type. IP NAT inside source static 10.0.0.2 20.0.0.4. Enter. Try pinging from 10.0.0.2, then you will be able to ping. Likewise, you ping from 3 and 4 after finishing these 2 lines. Can you do this? Okay. In case if you get any confusion anywhere in the middle, run through the video, go through the video, run this video, take notes, learn it proper, do it with proper understanding. See you in the next class.